So on this question, the series of questions, we want to find the limit as x approaches 2 from above of absolute value of x minus 2 over x minus 2. We also want to find the limit from below 2 and then also the overall limit. So what I know about this function here, this absolute value of x minus 2 over x minus 2, is that it's going to equal either positive 1 or negative 1, depending on what value of x we plug in. So let's just sort of test that out to make sure that you're on board with that idea. So if I were to choose a number like 3 and substitute it into this expression, you would get 3 minus 2 in absolute value over 3 minus 2. And that's absolute value of 1 over 1, which is 1 over 1, and that's 1. However, if you choose a number like 0, you would get absolute value of 0 minus 2 over 0 minus 2, and you have absolute value of negative 2 over negative 2. Absolute value of negative 2 is a positive 2, and a positive 2 over negative 2 is negative 1. So you can see whenever you end up with a negative inside the absolute value, then your top part will be positive and your bottom part will be negative, and you end up with negative 1. But whenever the inside ends up positive, both the top and the bottom are positive, and you end up with positive 1. So you always, no matter what number you plug in here, either get that positive or negative 1, I guess except for 2, which is why we can't use direct substitution on this one, because when you substitute the 2 in, you get absolute value of 2 over 2. Excuse me, I said that wrong. Absolute value of 2 minus 2 over 2 minus 2. That's absolute value of 0 over 0, and you get 0 over 0. So what's happening with this one, if we think about the graph, is that when we get to 2, we have a constant at 1 and a constant at negative 1. So when the limit is approaching from below, you're approaching a y value of negative 1. And when the limit is approaching from above, you get a y value of 1. So this limit here is a 1, and this limit here is a negative 1. And because the two limits are not agreeing with each other, then this limit does not exist. This question says to use the limit definition to find the derivative. And the limit definition of the derivative is f prime of x, the derivative of f of x, is the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. So I'm going to start this calculation by finding f of x plus delta x. So that means that everywhere I see an x, I'm going to change it to x plus delta x. This gives me x plus delta x squared minus 3 times x plus delta x plus 1. So next I'm going to subtract f of x. So subtract the original function x squared minus 3x plus 1. And all of this is divided by delta x. Now I'm noticing here that I left off the limit at the beginning, which is an important part. So let me add in that limit as delta x approaches 0. So now I'm going to start with my simplification. I have the limit as delta x approaches 0, and I'm going to multiply this part out. That multiplies out to be x squared plus 2x delta x plus delta x squared. I'm going to use the distributive property here to get minus 3x minus 3 delta x. Carry down that plus 1, and then use the distributive property on this minus. That gives me minus x squared plus 3x minus 1 all over delta x. And then we're going to see some things cancel out. We have a plus x squared and a minus x squared, a minus 3x and a plus 3x, plus 1 and minus 1. So what we have left is the limit as delta x approaches 0 of 2x delta x plus delta x squared minus 3 delta x over delta x. And we notice that all of the terms in the numerator have a delta x in it, which will cancel with the delta x in the denominator. This gives me the limit as delta x approaches 0 of 2x plus delta x minus 3. And now I'll use direct substitution to find the limit, and that gives me 2x plus 0 minus 3, and that's 2x minus 3. And this is the same as if we were using the shortcuts to find the derivative. Using the shortcuts, the derivative of x squared would be 2x, and the derivative of minus 3x would be minus 3, and the derivative of a constant is 0. On this question, I want to find the derivative of y equals 2x over 1 minus 3x squared. So to calculate the derivative for this, I will use the quotient rule because I have a fraction and variables in both the numerator and denominator of that fraction. So the quotient rule says that when you have a fraction and you want to calculate the derivative of that fraction, that you're going to have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So I've got in my numerator 2x and in my denominator 1 minus 3x. So I'll do the bottom 1 minus 3x squared times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. This gives 1 minus 3x squared. The derivative of 2x is 2. The derivative of 1 is 0, and the derivative of minus 3x squared will be minus 6x over our denominator squared. I'll use the distributive property here and just multiply here. This gives me 2 minus 6x squared plus 12x squared over 1 minus 3x squared squared. And I can combine like terms to get 2 plus 6x squared over 1 minus 3x squared squared. So we've calculated the derivative of 2x over 1 minus 3x squared to be 2 plus 6x squared over 1 minus 3x squared squared. I want to calculate the derivative of this function, f of x equals 7 to the x squared minus 2. So the rule we're going to use here is the derivative of a to the x. The derivative of a to the x, that's where a is any base, is a to the x times natural log x. And in this question, we have an exponent that is something other than x, so we have to build in the chain rule to this. So if we're thinking of this rule in terms of the chain rule, it would be the derivative would be a to the u, ln u, times u prime. So we would chain the derivative of the inside. And I can see that I've made a mistake in my rule here, so I'm going to go ahead and fix it. This natural log should be natural log of a and not natural log of x and u. So that's natural log of the base. So to calculate the derivative, it's going to be 7 to the x squared minus 2 natural log of 7 times the derivative of what's inside, which is in the exponent. So it's going to be 7 to the x squared minus 2 natural log 7 of 2x.